So we're going to talk about complex numbers. Complex numbers is a number that comprises of both real and an imaginary number. So a complex number is real and imaginary. Think if you have an imaginary girlfriend, that's considered a complex relationship.
Hey!
Hey.
That's crazy.
So, now, we should ask ourselves, what is an imaginary number? Let's first go through the history of numbers here. This is a review from what I talked about earlier. From the caveman times all the way to the Romans, our numbers was from 1 to infinity. Notice there is no Roman numeral for 0. They couldn't think of nothing. If you said, how many cows do you have? They would just say none. They couldn't think of that as an actual number. I don't have any. Now, 500 AD is when they introduced 0. How many cows do you have? 0 would be a number that they considered. That was 500 AD. Now, 17th century, so not long ago, about 300 years ago, they finally completed the number line, which included negative numbers. Talk about being in debt. I believe this was the Middle Easterns. What happens here? So if you go to any normal calculator and you do the square root of -1, you should get an error message.
Wait, go to.
Now, why do you get an error message? You ask who would take the square root of a -1? Well, it is basically, you have a number, let's say 3. You can do all sorts of things to this number, add, subtract, multiply, divide. What if I take 3 and multiply it by itself? I get 9. Is that the same as taking the square of 3? So 3 squared is what? 9. Now, usually you think of what's the opposite of squared? That's where you come up with square root.
Yeah.
So if I look at the number x squared, can I get a negative
No.
out of here?
No.
Anything squared is what?
Positive.
Always
Positive.
positive. So if a square will always be positive, then it makes sense that I can never take the square root of a negative.
Very, very smart.
Right? Because that's the opposite. Can't take the square root of a negative. Likewise, you can't square into a negative, or take the square and get a negative as an answer. But mathematicians don't like to be told no. So what they did was they took the square root of -1 and called it something.
I say no.
Oh, why is math so complicated?
They called it I. It's complicated because they ask these questions. Well, I want to work with the square root of a -1. What happens? That was 1777. So not even 300 years ago. So now that we can work with square root of -1, because now we're calling that I want to solve what's the square root of -4.
2.
Okay, hold on. I can break down square root of -4 as a square root of 4 and a -1. Square root of 4 is 2. And I just labeled square root of -1 as what?
So it's an I.
That's cool.
What?
So,
Who just made that noise?
so it doesn't. Okay, I understand.
Okay,
so
so-
you break it down into like.
Yes, break it down. Take that negative out.
Shut up.
That's a negative square root of 1.
Shut the hell up and do it.
And call it up. What happens when I take I and I square I?
You get 1.
Well, you get square root of -1 squared. These things cancel each other out
Equals -1.
because they're inverses of one another. And all you get is a -1.
Oh my god, that's like
Bro,
freaking.
math is so easy.
Are you stupid? This is
Very important. I squared -1. Here are the 2 most important things you need to remember for today. What is I? It's square root of -1. And then I squared equals a -1.
That's all you gotta learn to.
That's all you should remember
That's
Oh,
crazy.
from this unit. Now, it's called imaginary numbers because in 1777, all they had was pen and paper. Did they have computers?
No.
No.
Did they have 3D modeling software?
No.
No. All they had to work with was creating a tangent line here and call that your imaginary number. Basically, they're working with 3 dimensions. So I have X,
Oh, what is your problem?
Y, and Z. We have computers today and we can visualize imaginary numbers like so. So the blue is my y-axis, the red is my x-axis. Here's our normal xy plane. The green, the gray area, is my 3rd dimension.
That's cool.
So these green dots represent my imaginary numbers, or my complex numbers.
I don't know why. Today I knew I was gonna see a bunch of parabolas.
Yeah, we're going to be talking about parabolas next, actually. So,
Oh my God.
why do they call it imaginary? Because they couldn't have done this in 1777.
Wow.
Luckily, we can. So a complex number is both real and imaginary. Let's look at how to add, subtract, multiply, and divide complex numbers. Adding, in this case, 2 plus I plus 3 plus 4I, just requires combining your like terms. Take your real numbers, 2 and 3, and add them together. 5.
That's easy, dog.
Yeah. Take your imaginary numbers, I and 4I, add them together. 5.
That is
Hold on, hold on, hold on, hold on,
crazy.
hold on, hold on.
We should have went to 4.
This 4 got added to this I, 5I. So your real
Oh, that's that right there.
Oh, Baba boy.
and imaginary. You're just combining like terms. Reals can be added with reals,
I didn't-
imaginaries
I
with
didn't
imaginaries.
see that yellow combined like terms right there.
Well, excuse it, so.
1 9? Yeah.
Oh, I'm
Right,
tripping.
right.
So y'all are really dumb. How did y'all not see that?
Easy.
Yeah.
We confused?
No, no, no.
You think? Okay, good.
Ferber is
Yeah.
So,
pinche rana.
Herbert.
Herbert. You said Rhino?
when I want to subtract, remember, we do not subtract.
We distribute.
We think of addition where I, yes, distribute this -1. So distribute that negative across with a 3 gives me a -3. Distribute that -1 across to this 4i gives me a -4i. And now again, we combine like terms. So take my real numbers, 2 minus 3, -1. And take my imaginary, I minus 4i is a -3i. Combine like terms.
That's so easy.
Oh my God.
Before we get into multiplying, let me look at properties of I. So we already saw this one, right? I equals square root of 1. I already told you that if you square I, you get a -1. Well, what happens when you cube I? Well, that's these two multiplied together. So you get a negative square root of I. And what happens when you take I to the 4th power? You get I squared squared.
Oh, forward.
So that's a 1.
Oh,
Oh,
okay. I
no.
get it. I get it.
This is the main one though. Knowing that I squared equals -1.
That's some big math right there.
Not really. That was just special. Okay. Now we know I squared equals -1, let's multiply, because it will show up. We multiply just like we normally do. You can treat I like a variable. So let me take 2 and multiply by 3. 2 times 3 is 6. Let me take 2 and multiply by 4i. 2 times 4 is 8i.
Man, this is really, really easy.
It is.
Bro, don't
I-
ask for help later on.
Times 3
I know you can relax.
is 3i. Here's the tricky part. Here's the magic. I times 4i is 4i squared, but what's I squared?
Equals -1.
That's a -1, so it's actually 4 times -1, which is -4. Again, remember that I squared is a -1. It will show up with multiplication. So now we have real numbers we need to add together. 6 minus 4 is 2. And imaginary numbers. 8i plus 3i is 11i's. Think of I like a variable. Add it, subtract it, multiply it like you would a regular variable.
Hey.
Now when we divide, it works the same as radicals. We do not want imaginary numbers in the denominator because math. So what you need to do is, how do you turn I into a number on the number line? Well, you multiply I by itself.
Multiply by itself.
Get you -1.
Math.
Because math. So I need to multiply the top and the bottom by I here. So that gives me 4i on top. And I times I is I squared, which is a -1. Do you see any i's on the bottom? Nope. So we're done. That's all we need to do. Is just get I out of the denominator. Now, if you get a complex number in the denominator, it's not as simple as multiplying by I. Because even though I get I times I, and that's -1, I also get this I times 1, and I still have an I in the denominator. Oops. So just like with the radicals, we need to multiply my complex number by the conjugate. What is the conjugate? If you have A plus bi, then your conjugate is A minus bi. And vice versa.
Okay.
So if I have a 1 plus I, my conjugate is 1 minus I. If I have 5 minus 3i, what's my conjugate?
5 plus 3i.
5 plus 3i.
5 plus 3i.
6 minus 7i, what's the conjugate?
6 minus 7. 3 plus 6 plus 7.
6 plus 7i.
Damn.
Flip the sign in the middle.
Freaking smart.
Because this is what happens. I get 1 times 1, which is 1. 1 times negative I, which is negative I times 1, which is plus I. And I times negative I is negative I squared. I note that my i's cancel here. And what's I squared?
Negative 1.
A negative 1. 2 negatives here makes a positive, so that's where I get my 1 plus 1 is 2. And on the top I have 3 times 1 is 3. 3 times negative I is negative 3i. So multiplying a complex number by its conjugate gets rid of that I, which is our goal when we divide complex numbers. Now you're in luck. Not only are you in the 21st century and you have 3D maps that you can visualize, but we also have a nice graphing calculator. So as you see here, this says what? In real mode, all calculations must result in a real number. Well, if I go to mode, oops, let me close this. If I go to mode and scroll down here, I'm in real mode, but if I set it to complex numbers, I can work with complex numbers. So let me go back and do the square root of negative 1. It is what?
I.
It is I.
J. I.
That's an I.
It's an I, boy.
So bad.
What is I? How do you type in I? Look right here by the period. A blue I. So second period, I squared is
Negative 1.
negative 1. What is I to the 4th power?
1.
Very good. That is 1. So your calculator can help you with complex numbers. Remember, there's the I button by the period. It can also help you check your work. Note, check your work.